In this short tutorial, I'm going to demonstrate how to solve each one of these equations. Notice that each one of these equations, there's no additional adding or subtracting or multiplying outside of this group. Outside of this group, there's no adding, subtracting, or multiplying. And what I mean by that is if we look up above, this is in parentheses. This is not. So again, this is the main group I'm talking about. This is this additional stuff I'm talking about, whether it's right out front or whether we have it in back. There's nothing additional to it. So when I have the exact log base on both sides, I'm able to actually cancel them out. I have 2x equals 5 divided by 2, x equals 5 halves, or 2.5. Let's go across. Now, in this situation, I think it's going to be to our advantage. Notice this problem is different than this one. Here I have log on both sides. Here I only have log on one side. I'm going to rewrite this in exponential form. So I have the base, 25, raised to the opposite side, equals, I come back, equals the answer, 1 over 5. So what do I have to do to 25 to turn it into a 5? And remember, I can only do this using an exponent. Well, I know the square root of 25 is 5, and we can represent the square root as a rational exponent as 1/2. Not only does x equal 1/2, the 5 has been moved from the top to the bottom, making the exponent negative. Let's go over here. Again, similar situation. The base is 7. We're going to raise it to the opposite side, which is 2, and it's going to equal this answer. 7 squared is 49. Situation here. We have 8 raised to what exponent equals 1? This is sometimes a tricky one, and a lot of students want to write 1. Remember, any value raised to the 0 power equals 1. Down here, this is going to be the same type of equation as we have up here. And why is that? Because ln, known as the natural log, is really log base e. So in this situation, we have the exact same basis. There's no additional adding or subtracting. X is equal to 9. All right, this problem is like our first one and like our fifth one. We have log base 11, log base 11. The difference here is notice how we have parentheses. It's not just simply an added or subtracted behind. I can cancel out, and I have 2x minus 3 equals 4x minus 13. I'm going to subtract 2 to the opposite side and add 13 to the opposite side. So the 2x's cancel, my 13's cancel, and I have positive 13 and negative 3 is 10, and 4x minus 2x is 2. I end up with an answer of x equals 5.